7.7 talks about different types of proportions as well as variations. The first type of variation that we talk about is when something is directly proportional, which also is known as varies directly. Once we see that something varies directly, we know that it's going to be in the form of y equals kx. Or here we have c varies directly as d, so we can actually write this as c equals kd, where k is what's called a constant of proportionality. So the first thing we need to do is we need to be given enough information to find our constant of proportionality to write to write an equation, and then we can solve any other values of c or d based on the other. So we're given c equals 9 when d equals 11. We can use that to first help us write our equation. So we have c equals kd. We're going to plug in 9 for c and substitute 11 for d. 9 equals k times 11. And then we solve for k by dividing both sides by 11. And in order to leave our answer as exact as possible, let's get that focused there. There we go. In order to get that our answer as exact as possible, we want to leave it as a simplified improper fraction, so that way we can work with it. So I'm going to leave it as k equals 9 over 11. That gives us the equation that we can use for part 2. C equals 9 over 11 d. Once we find our equation, we can go ahead and solve. Here it says find c when d equals 33. So we're looking for c equals, and we know that d is 33, so we multiply and substitute 33 in, which means we're multiplying. I'm just going to put 33 over 1. We can cross reduce our 11 and 33. Both are divisible by 11. That becomes 1. That becomes 3. And now we multiply straight across. C equals 27 over 1, which just means C equals 27. You could go ahead and plug that back into your equation where we substituted D in 33 in for D, just to check to make sure that works. 27 equals 9 over 11 times 33. Again, you don't have to cross simplify. I like to cross simplify though because it gives us smaller numbers, and smaller numbers are easier to work with. 27 equals 9 over 1 times 3 over 1. And look at that, 27 equals 27. So we know that that definitely is our solution. So that's when something varies directly. We also have another situation when something varies inversely. Here. When something varies inversely, let's get some highlighting going on there. Instead of using the equation y equals kx, we use the equation y equals k over x. And again, we don't have x and y in our problem. We have g and h. So that means that we're going to use the equation g equals k over h, right? The first variable that varies inversely, the first variable is what we're solving for, y, and the second variable is our independent variable. So here we have our h. So again, I don't want to do that. Our first step is to find our k, our constant of proportionality. We're given some initial information when g is 3 when h is 48. So we start by substituting 3 for g, 48 for h. 3 equals k over 48. In order to solve for k, algebraically, we need to get rid of that denominator. So we're saying k divided by 48. The opposite of dividing by 48 is multiplying by 48. Whatever we do to one side, we do to the other side. And we get k equals 48 times 3, 24. I don't have a calculator in front of me. 12, 13, 14. There we go, 144. So that is our constant of proportionality. So we have G equals 144 over H. Now we can use that equation, G equals 144 over H, to solve for G when H equals 2. G equals 144 over 2. Well, we can definitely simplify 144 over 2. So G equals 72. And just like before, you could take this value G, the given value 2 for H, and substitute it back into your equation to make sure that it will work.